Alright, I am doing a recap of day 12. We started with a warm-up where I asked people to decide in their groups what is the equation of the line segment S and how long is this line segment S. And then I gave people a small amount of time to work on that. Now is the time to pause if you want to do it yourself. So for the equation, For the equation, part A, since it goes through 0, 1, and 1, 3, you can use your own information. I'm going to do it by saying, alright, so when you go from 1, actually I'm going to start from this point. Alright, as you go from this point to any other point, what's my change in x? Well, that's going to be the current value of x I'm at, minus 1. Alright, now, how much is change in y going to be? I can look at this to find the slope and say that's going to be 2 times x minus 1 is going to be the change in y. And then if I add my old y, which is 3, I get my new y. On the other hand, what is the length? Well, there is a triangle, a right triangle made here that has a base of 2. No, base of 1. What am I saying? And a height of 2. 1 squared plus 2 squared. Or square root of 5. So make sure that you're being clear between the length of a segment and an equation that describes all the points. It describes all the points by describing the relationship between the points x coordinates and y coordinates. Okay, I'm going to clear this. Alright, let's go on and say now, what is the equation of the line segment S and how long is this line segment? And again, I gave people time to work in class. Alright, what is the equation of this line segment? Well, if we look at this line segment, what do they all have in common? Do all of these points have the same distance from the y-axis? No. Do they all have the same distance from the above the x-axis? Yes. So they all have the same y value. And what is this y value? What is this height above the x-axis? Oh look, it's the same as this height. Therefore, this height right here all the way. Therefore, we can describe the y-coordinates of all of these points using the output of the function f when x is c, because that gives us this length. So y equals f of c. All of the y coordinates of all of my points here have the same y coordinate as f of c, have the same measure as f of c. Alright, but I don't want it to go forever. I just want it to go from here to here. What am I limiting? Not the y coordinates, I'm limiting the x coordinates. And therefore x has to be larger than a and smaller than b. If I wanted to know how long this line segment is, well, it goes from b to a. And you can think about that as, what are x coordinates again? Distance to the right from the x-axis. Here is a bar whose length represents b. Here is a bar, whose length represents a. Clearly, if you take this bar and then you subtract this bar, you get what's left, which is this much. And look, the length of that is exactly the same as the length of S. So the answer is B minus A. Alright, I'm going to clear this now that we've started to talk about the difference between describing the equation and the length of it. We're going to go on to continuing to talk about constant rate of change. So the first thing I asked you to do is to use a computer or phone to answer the online participation quiz. And the question was, if y with respect to x has a constant rate of change of 4.2, explain the meaning of 4.2. And I gave you a hint. What can you predict? There's also a hint right in the question itself. It's a constant rate of change. After you answer that, we went over it. You cannot say, for example, that y is 4.2 times as large as x. That is absolutely false. If you think about those times when I made you fill out these two equations about a bunch of different points, do you remember how we always got the same number here since we were working off of a line, but we did not get the same number here? That's because y is not always the same amount times as large as x, but dy is always the same amount times as large as dx. So dy, the change in y, is always going to be 4.2 times as large as the change in x. That's what the meaning of the slope is. You can't tell me that you get 4.2 by dividing it, because that's only telling me how you get it. It's not telling me the meaning of how it can be used. If I ask you for the meaning of something, you don't tell me the calculation that gets it there. You tell me how can it be used. Alright, I'm going to clear this and move on. So, at 78 degrees Fahrenheit, the crickets chirp 60 times a minute, and the cricket chirps with respect to temperature have a constant rate of change of 0.3 chirps per degree. How much will they chirp at 39 degrees? So first, I'm going to go ahead and write for myself, my constant rate of change is 0.3 chirps per degree. That means that this is my independent variable, or independent quantity in this constant rate of change, and this is my dependent one, my dependent quantity. Now, I could definitely switch this, but then I would have to have a constant rate of change of 1 over 0.3 degrees per chirps, right? So that's why I need to keep track of which way this is. This is the constant rate of change of chirps with respect to degrees, not degrees with respect to chirps. I'm going to go ahead and erase that. And so now I'm going to say, so what am I looking for? I'm looking for how much will they chirp. Okay, how much will they chirp? Not a change. I'm looking for a total chirping. So that's going to be my total y at 39 degrees. All right, that's going to be my x, my new x. And I also have an old y and an old x right here. So I'm going to draw myself a sketch of a graph. Again, I don't try to make it perfect. It's just dots in order to keep track of things. When it is 78 degrees Fahrenheit, the crickets chirp 60 degrees. So if I'm trying to get to 39 degrees, I know that I need to have a change in degrees until I get to 39 degrees. So what is this change? Well, if I go from 78 to 39, my change is 39 minus 78. That's my change in degrees. How does that help me with chirps? Well, it's the magic of this constant rate of change. It says the change in chirps is always going to be 0.3 times as much as the change in degrees. So now if I choose to multiply this by 0.3, this gives me a change in chirps. So right here, that's my change in chirps. However, that doesn't tell me my total chirps, right? If this is change in chirps right here, total chirps is actually this, right? This new point's distance above the x-axis. So what I need to do is add how much I had at the beginning of chirps. At the beginning, I had 60 chirps per minute. So here is my answer of how much they will chirp at 39 degrees. And here's the last question that we did. My desert lawn only grows when it rains at a rate of 0.15 inches of growth per inch of rain. Over the weekend, we got 3 inches of rain and my lawn is now 2.4 inches tall. How tall was my lawn before the weekend? Alright, I'm going to draw a graph for myself, and I'm going to ask myself, alright, what is my independent and what is my dependent? In this, inches of growth per inch of rain. So that is my independent, and inches of growth of my lawn is dependent. So, over the weekend, we got 3 inches of rain, and my lawn is now 2.4 inches tall. So it's 2.4 inches tall. Oh, sorry. 3 inches of rain, 2.47. So first I look at my constant rate of change and I say, oh, 0.15 inches of growth per inch of rain. So inches of rain is my independent quantity. And then that causes the inches of growth, the change in growth, to be 0.15 times as large as the change in rain. That is my dependent quantity. Alright, over the weekend we got 3 inches of rain and my lawn is now 2.4 inches tall. So right now I have 2.4 inches. How tall was my lawn before the weekend? So what I'm going to do is I'm going to just say we got 3 inches of rain. So notice, that's my change. Right? That's my change in x is 3. And then I got 2.47 inches. So what if I want to go backwards in time from Sunday to Friday? Well, what's my change in inches of rain? -3, because I'm going backwards. And therefore, as I go backwards, as I rewind my video from Sunday to Friday, what will happen to my growth? My growth of my lawn will change by 0.15 times -3. Here's dy, here's dx. Notice you didn't have to subtract for dx this time because I just only gave you a change. Right? I didn't tell you how many inches of rain total my desert lawn had got, only that we got an extra 3, an increase of 3 over the weekend. Increase of 3. So this now tells me my change in my lawn, but I need to add that on to what my lawn was like at the beginning, 2.47. This is how tall my lawn was before the weekend. And that's what we did on day, I believe, 12.